Hello, my name is Daniel Adievich. I work in AppDynamics Professional Services as a solution architect, and I would like to talk to you about AppDynamics DEXTER. DEXTER is a utility that I wrote. It stands for Data Extraction and Enhanced Reporting, and it allows people to take out the data from inside of AppDynamics platform to preserve the data for the longer period of time that is supported in our platform, and to report against it in various ways. It works by grabbing pieces of data sent there into AppDynamics platform by the agent API and use it after adding some compute as the inputs into a variety of analytic tools such as Excel, Power BI, Tableau, and other visual tools. Today, I would like to discuss flame graph reports, which are a very interesting way of looking at the call stack data. First, let's take a look at AppDynamics. Here on my screen, we have a view into a certain activity, business transaction, that spans multiple runtimes. Each one of these circles represents a certain runtime. This is a 2 JVMs, there's a JVM here, there's a JVM here as well. And they are talking to a variety of components such as queues, databases, and websites. At any point in time, if there is an interesting performance event happening, such as a slowdown or errors, AppDynamics agent may take a transaction snapshot. Let's take a look at one of those. Here's a 42-second transaction snapshot. Inside of the snapshot, I can drill down into the details and take a look at the call graph elements and associated exits made by the specific pieces of code to your destinations. Here we have some Java code, and I can scroll up and down. I can see interesting results in it. This view is incredibly powerful and allows you to jump between multiple segments of a snapshot to investigate performance slowdowns. Here, I'm able to drill down from struts call into a web service call on a separate server altogether and see exactly what database exits, database queries were made. Now imagine if you wanted to take a look at the call graph elements, not just in one snapshot, but in all the snapshots that are present on my screen right now. Here we could see that we have exactly 213 snapshots up in the right corner. If I expand the time range, I may have hundreds more, if not thousands, if not tens of thousands. What to do? AppDynamics DEXTER extracts the data, as we've seen in other previous tools. And the data, after it's extracted, gets turned into very interesting visual representation. On my screen, I have an AppDynamics metrics report that allows me to see the performance of my subcomponents. There's two controllers, Demo 1 and Demo 2, full of interesting pieces of data. If I scroll further to the right, I can observe, let's actually put it here on the right side of things, I can observe that there's links, and there's a link in the column X and column W, X, and the Y. I'm going to click on the flame graph for my checkout for my e-commerce application. See what comes up. Here you go. Put this on the left side of things. This opens inside of my Chrome tool the view into the call graph elements associated with an entire application. I'm going to zoom in, actually resize it a little bit more, and look through it. So the flame graph is a type of an adjacency diagram that is used to visualize the arbitrarily large number of call stacks. It could be read in the following fashion. Every call stack begins at the bottom and goes up. Every frame of a call stack is a rectangle. The width of the call stack frame is proportional to its representation and frequency of observation. So for instance, as I zoom over the struts action proxy execute, I can see that it is present 31% of the time in all of my call stack samples at this first element at the bottom. So thus it's pretty wide. If I look up at its children, here I have a call called send fulfillment. It is present only in 6% of the elements. That's why it's more narrow. As you go up, the frequency of the calls typically decreases, and that's why the things look a little bit like fingers of flame or whispers of flame. That's why it's partially called flame graph. Now you may also observe that the flame graph representation here takes heavy advantage of the colors. The colors are important. Colors, if you turn on the legend, are assigned by AppDynamics DEXTER to certain frameworks. So for instance, we could see Apache FreeMaker is using a pink color. Java is represented by a warm color of green. Glassfish is more of a puce. And AppDynamics has kind of a light purple, and here and there, Sun Woodstock's framework is interspread in yellow. At any point in time, you can turn off the legend if you don't want to see it. The way I like to use flame graphs is to, at first glance, understand the types of frameworks that are involved in my application. Here, we see a heavy usage of Java. If you take a look over here, we see Java in green. So we can conclude that this is a Java-based application. I could see a pretty heavy use of Spring Framework, so there's going to be some sort of Apache and Spring playing together. We also see code, my custom code, Calm AppDynamics, is present in here. Let's compare this with some other application. So we have an application called Movie Tickets Online here. Let's take a look at its flame graph. Observe, now here we can immediately see, even by looking at the top right of a legend, that different types of frameworks are dominating here. There is a lot of .NET. Here we can see a .NET in blue. There's also Microsoft Service Bus in a slightly different color of blue. And then we have a variety of frameworks associated with what it appears to be custom code, largely movie search namespace. Some red, deeper red, lighter green, and so on and so forth. So right off, immediately I can observe that this is an application that most likely uses Microsoft .NET framework and utilizes whatever frameworks afterwards interspread with their own code. At the bottom, I could see all the Microsoft code, Microsoft framework code, interspersed with the custom code. There is also a kind of green. This is a Node.js color that's taken by AppDynamics DEXTER to represent Node.js call stacks. Let's take a look at one more example just to see what it looks like. And why don't we bring up AD Financial? Here we go. AD Financial, zoom in a little bit more, has even more different colors. Right, again, in the legend, we can observe and see that there is Java code. There it is. We could see that there is some Google code. Let's wrap some squares and using Google Orange. And there's also MongoDB. So we can conclude that this is an application that uses Mongo database drivers, and it probably utilizes some sort of library that got picked up from Google. Just the colors alone are enough to give us an understanding of what is it that we're looking for. Is it a dog? Is it a cat? Or is it a porcupine? Let's see what else is available as you use the flame graphs. The flame graphs are interactive, so I can mouse things over and see what's going on with a specific method. I can click on one, and it expands to fit my screen. I can turn off the legend. I can do a search. I can look, for instance, for the framework code. How about I look for a word service in here? Here you go. Everything that has a word service gets highlighted in pretty bright color of pinkish red. I can reset the search to move it out, and now I can investigate the specific calls. So how about if I click on this element right here, the get quote. This is a get quote. It's present 77% of the time in my call element, as indicated by the percentage graph at the bottom of my screen. I can also see that it gives rise to other different methods in my custom code, and a certain thick red border with the dashes is outlined in here. So the thickness of the border is proportional to the duration of the element. So for instance, if I take a look at that element, we can see that 41 samples in here on average took about 990, well, almost 10 seconds. So that's a slow call. The fact that the fact that it's actually dashed means that there is an exit call. In this case, we can observe the specific exits in my flyout menu. We're making web service calls to some sort of quote service. I also have in here a red call that isn't it dashed. That means that this method was just slow. We have some sort of a Java object wait, some sort of background worker clearly waiting for the thread to complete. So let's see what else we got, different flavors. If I turn on the legend and zoom in maybe a little bit more, we can see that in the legend, it explains the semantics of these things. You can have a red border around the slow method. You can have a blue dash border around the method that represents an external call to it as a system. Or you can have a red dash border which represents the slow exit call to a certain destination. So if I zoom out a little bit here and take a look at one of these elements, how about this right here? I could see the custom code. It looks like some sort of a web service servlet made a slow call to to a Java object length to do background, but it also there's a certain exit in here, like synchronous activity. It went to a different thread, or a call to a Mongo database right here. And how about right here? There's a call, but there's a Mongo, finally an HTTP call to a service that made a Mongo database query, but it's not very slow, which is why it doesn't have the red border. What else can we do inside of the flame graph? So we already explained that we can zoom in and zoom out. We can search for things. We can change the context of where we're looking at in the flame graphs. I started from an application view, so I'm looking at all the call stacks in a given application. Using either an entity, APM detected entities or entity metrics report, I can actually change my focus to either a tier or a node or even business transaction. Let's take a look at what happens on a specific tier in my application. Switch the focus to the tiers view. I find my controller, demo 2, maybe find an application. How about I will take a look at my e-commerce application, and I see that the columns for I still have my flame graph views right here on the right. I should be able to click on each one. Oh, this one doesn't have it. How about this one? Flame graph. There we go. So there is an e-commerce services tier representing only the call graph elements associated with this type of executable. I could see and compare and contrast it maybe with another executable. There must be some others. There you go. Here's my web services tier. As you can see, the two call stacks are quite different from each other, but they really come together in an overall application view. The same access is available for the nodes and the tiers. I hope you enjoyed looking at the flame graphs as much as I enjoyed building them for you. Thank you.